Right, so .NET Bridge. Now, we all need to be very careful not to call it the .NET Core Bridge, because from version 19 onwards, we're using .NET 5, and Microsoft's branding for .NET 5 removes the word core. So I'm going to try very hard and use the words .NET 5 rather than .NET Core throughout this presentation. I'll almost certainly not get that right, but please bear in mind that it's .NET 5, not .NET Core. Before we get into .NET 5 though, let me just give you a quick example of what I want to talk about. The big difference between .NET Core, .NET 5 support in version 19 over version 18 is the ability to expose APL code as .NET Assemblies. A quick little bit of revision of that. First of all, this is version 18. I am going to load a workspace called reverse, which contains a thing called reverse class, which just contains one function that reverses its argument. And then in version 18, I can do file, export, okay, and create a .NET assembly, okay, that contains that function. And then from any language that can use it, including Dyalog' APL, I won't use that on the data, I'm running out of time already, and we can load that assembly and run the functions that are within that. Microsoft have a tool called ILDASM that we can use to look at the contents of a .NET assembly. And if we look at this thing called reverse.dll that we've just made, we can indeed see that there's a thing called reverse class in it and a function called reverse that has some implementation. In fact, we can double click on this and see all the MSIL that is the implementation. Now, in the framework bridge, all of this IL has been handcrafted by our .NET Bridge using the reflection emit APIs in the .NET Core. So we've handcrafted each of these instructions in order to get the behavior that we want. Unfortunately, the ability to do that is not in .NET 5.0. So in 5.0, we have to do this in a slightly different way. So what I've done now, oh, well, let me increase the font size again. I do apologize. Okay, that's probably plenty. First of all, I'm just going to delete that thing from there. Okay. So this now is an interpreter that's configured to run .NET Core. I can load exactly the same workspace. I can do exactly the same thing. I can do file, export, and I can save this to the same directory. Okay, and the process now is slightly different. Because we're not able to write that MSIL ourselves directly, what's actually happened here is that we've created C# source code that defines the public entry points for our assembly, and that C# source code calls into our .NET Core Bridge. Also, there are a number of additional dependencies for our reverse.dll that we've just made that .NET Core has over .NET Framework. Specifically, things like these JSON files that determine the runtime dependencies of such a thing. We'll also see in here that we've got a number of files that are named for Linux and OS X versions of the .NET Bridge. The reason for this is in order to make this completely cross-platform, we do need to have some native elements, including some little, well, in fact, first of all, including the interpreters themselves, and secondly, including a little bit of managed code to get us between .NET and our interpreters. On my machine, because I've installed all the binaries for all of the operating systems, I have all of these binaries available to me in my dependencies. And inside this directory reverse.build, we actually have the C# source code that the interpreter has created, which is then compiled as if it were any other .NET 5 project. Oh, something else we can do if you I'm going to delete all of this stuff. Okay. Something else, another way of exporting this stuff is that we can use 2QuadMQ. So we can say 2QuadMQ, we're going to bind all of our stuff together. We're going to create something called Dyalog'20/tump/reverse.dll, and we want this thing to be a .NET library. And that just goes through the whole process, but we can do that with an APL statement rather than having to use the GUI in the development environment. Okay, now in order for so what we've done is we have created a .NET assembly that contains our reverse class containing our reverse function that takes an object as an argument and returns an object as a result. Now we could use this directly from Dyalog' now as we can use any other .NET assembly from Dyalog'. But if we wanted to use this from C#, it's a little bit more complicated. The way .NET 5 wants us to create applications is much more project-driven than it would be with the old framework approach. And I just want to now talk us through the steps for creating a program that will make use of that reverse library. So what I'm going to do, I'm going to go into my temporary directory and I'm going to make something called tester. Just make a directory called tester. I'm going to go into tester, and now I'm going to run some standard Microsoft .NET project commands. I'm going to create a new console application. Okay, and that's going to create a console application inside this directory that I've folded. I can now just run this thing, and it will follow the theme for today. It will just say, hello world. The reason it says hello world is because the .NET new command has created a new program for us. It's generated some source code that just says hello world. If we want to extend this program so that it can call our reverse function in our reverse assembly, we need to add a reference to our reverse project, which is in the parent directory. Okay. And we can see if we look at the C# project file for this, that a reference has been added. Now there's one additional step that I need to make here that hopefully when we get this to release we're not going to need, but I'm just going to read in this thing called targets.txt, which just imports a little bit more information about the parent, about the reverse build project that we need in order to be able to run this thing. But now, finally, of course, I need to modify my program so that it calls the reverse class function. So we're going to add some code here. We're going to create a new instance of reverse class. We're going to call the reverse member on it, on hello world, and we'll make sure we spell reverse correctly. And now we can .NET run. But in fact, we can build it first. And then we can run it. And that will reverse, it will call into APL and reverse the text that was in hello world. So that has called into that .NET, that workspace that we exported as the assembly from the C#, and it's passed the arguments in and reversed the text and so on. Now this is portable, so this directory that we're in at the moment, the reason this is called Z is because this is a networked mapped drive, and it's mapped to a common location. All of these machines that I'm working on can see the same common location. So if we go into the temp directory here, we can see all of the files that I've just made. They're all timestamped right about now. I can go into tester. This is portable. So touch wood, I can now just run this here. And in fact, let's be even more specific and say, don't even bother building it. Just run the thing. Okay. That was always going to be a bit of an ask. Let's build it here. There's an issue here, and I haven't quite got to the bottom of it. Depending on what order I run them in, that works or doesn't work. And I will flip forwards and backwards a little bit. So that's now working from the Linux build environment. Let's come back to Windows. Let's run the thing from here. Again, without building it. Okay, so the one that we built on Linux will run on Windows. In fact, I can prove that. Let's go back to the, well, let me just have a quick look at my notes. Okay, blah, blah, blah. So we've done that. Oh, okay, right. So my instructions now tell me to go to my Linux machine. So what I said was, this is a regular bog standard .NET project. It's a regular bog standard .NET project. That means we can now edit this in VS Code. So here I have VS Code. Now I appreciate that the font may be a little bit small. And in VS Code, I'm not entirely sure how I make it larger. Okay, but I can now change this. Let's just change this to, now we could do some palindrome jokes here. Okay, so we've modified the text now in C#. We're inside VS Code, a commonly used development environment for doing .NET 5 development. I can now build my program and run it from here. Hold on, we can run our program from here. And hopefully our palindrome works, and our Madam, I'm Adam, which is the same backwards as forwards.
Can you make the font any larger, John?
Let's see, let me have a look.
Control plus.
Oh, is it just Control plus? Is it as easy as that? Okay, so it's as easy as that. Oh, is that too much?
Yes.
Yes, I thought so. Is it something as useful as Control minus? There we go. Okay. So now we can see that we can just edit our call in C# code in the completely standard tools, and everything just works. We can do this. We can run the thing again. So, you know, our Dyalog' APL project, our Dyalog' APL assembly is actually just like any other project and assembly that might be written in any other language, as far as, you know, incorporating it into a larger environment is concerned. Okay, so everything's being reversed correctly. Let's move on to a third operating system. Okay, so we're now back to our Mac, and I'm going to, what am I going to do? I'm going to throw away everything that we've just done. Okay, and I'm going to show you, here's some APL code in a file called .apl. It could be .apln, I think is the naming convention that we have these days, because it contains a namespace. But it contains a namespace that contains a function called hello. The theme for today is just saying hello to everybody. So when we call hello, this is going to write to stud out, hello world, this is APL. This was built on, and then some information that tells us where and when this program was was built. So essentially, expressions like this are run when this namespace is fixed rather than at runtime. But rather than starting a session and either going to the export menu or doing the 2-quad enqueue from the session, I'm going to use one of these scripts that we talked about earlier. So inside my scripts, I have a thing called build.diascript, okay, which does some processing of the arguments, as we saw with the disp case earlier. But eventually, it just sort of falls down to a 2-quad enqueue bind type thing. Now, I've unfortunately done things slightly out of order here, but never mind, we're probably going to be okay. So what I'm going to say is, using that script, I want to create the thing called hello world, and I want to compile the text that's in hello world.apl, and I want to create a executable.
John, I can't see anything that you're typing.
Oh, is it off the bottom of the...
It's off the bottom.
Right, okay, hold on, let me just resize things a bit.
And 11 minutes to go while I'm here.
Yeah, thank you. Okay, so can you see that now? //scripts.
Yes.
Okay, so what this does, oh, and let me just go back and show you, presumably you saw this. So what that command is going to do is that it's going to process all of the arguments that I gave to the script, resulting in a call on bind, exactly as we saw in the Windows section. But this time, of course, we're running on the Mac. And so we run that. Okay, and inside Tump now, we have a bunch of things, including this thing called hello world.dll. Now I realize that I've done this on the wrong machine, because in order to run that as a standalone program, I actually need to use the .NET command to run it again. So let's just run this. Okay, but this is telling us that this program that we've run was created on Darwin. That's the name of this machine, or the name of this operating system, was created at 4 minutes past 16 on the 9th of 11. So about a minute ago, which seems about when I did the /build.diascript. Now the same thing actually works on the other operating systems as well. If I come back to Linux, okay, I can do, I'm going to throw away everything that's in temp. I'm going to do scripts /build.diascript temp/hello world, and the text is jd/hello world.apl, and we want to create an executable. So it does the 2-quad enqueue bind, then throws that at the .NET stuff to build the C# that we generated. But the difference between running this on Linux and actually running it on Windows is that what we actually end up with on Linux and on Windows, if we go into Tump, is that we actually end up with a program that we can run directly without needing to run that .NET bit in the middle. On Windows, we would have hello world.exe. Okay, this is a native Linux executable. Okay, so this the notion that we can build binaries which are portable is true in that we can build assemblies that are portable. If we want to build a standalone executable, a .exe or an executable as we have here, then it seems that the implementation is different on the different operating systems. And I think that's a .NET thing. I'm going to continue to investigate that, because it would be nice if we could build a self-contained executable binary that would work everywhere. But at the moment, we're not quite there. I'm going to finish with a slightly more complicated example of this. I'm going to throw away everything that's in my temporary directory and start again. I'm now going to show you, this is a, in fact, let me not do it here. Let me show it to you on Windows. I'm going to load a workspace called component file. Okay, this contains a class which contains a bunch of things from reading and writing to component files.
Font
Okay.
size.
Sorry?
Font size.
Font size, yes, sorry, yeah, right. Okay, so we have a component file class which has a constructor which takes a file name and it fs ties that file. We have a property on here called count that returns the number of components on the component file. And we have a property called components, which is declared as being the default property, but it takes an index into the component on the file. What I'm going to do is I'm going to create a file called test.dcf, and that's going to put 4 components in that component file. Okay, I'm now going to create, I'm going to export this as an assembly in the temp directory. Okay, so we created some C# source code. We're now compiling that C# source code. We have this thing called component file.build. I'm going to make a directory called C files. I'm going to cd into C files. I'm going to .NET new console application. I'm going to add that reference to our component file.
You think you're able to up the font in the bash as well?
Yes, sorry, of course. Text. So now it's all disappeared off the bottom, I should imagine, but okay, hold on. Okay, so I'm just going to add the same bit that I added before. I'm just going to read this extra bit of stuff in.
And 5 minutes, by the way.
Yeah, no, I think we're bang on. Okay, I'm just going to change these texts here from reverse to component file, because the rules within are exactly the same. We just need to use this to get the files that we need for the different operating systems. Component file. Okay, I'm going to edit our CS file. I'm going to bring in a snippet of code from above, which is called cf.cs. So what this is going to do, this is going to create a new instance of our component file class with the correct name of the file, which is just test.dcf. I didn't put it in temp this time. So let's just delete that. And then it's going to go through each of the count items that are in the component file and use the default property, which is a component property, to dig out the component. And assuming I type, oh, the hello world was just from the default program. So there are all our components. Furthermore, what we can do is we can overwrite one of those components. So let's bring in another snippet of code. So this code is now changing the value of a component on the file to replace, well, to component 2 written plus whatever the timestamp is now. Then it's going to enumerate the content of the file again. And we can see that our second component will have changed from component digit 2 to component text 2. And if we now come back to our session, and read that file rather than create it, we can see that that change to the component has been done over here. Now again, just for the final hurrah, if we move back to the C files thing here, I'm going to try and run it here. And everything that we've done there, you see, we had the component that was written at 16.13.00. We've now written to it again from our Linux system. Everything works in exactly the same way. So it's portable as much as we can make it, given the portability of the .NET Core framework, .NET 5 framework itself. That is, broadly speaking, what I wanted to demonstrate today. I've got a few notes about things that we might want to address in the future. A lot of this implementation is incomplete. So first of all, we need to finish off the bits that aren't quite there yet. But one of the targets I've got for version 19 is to get all of this working within the ASP.NET.Core framework, which is the Microsoft's web server backend, because then I can implement the web version of the Spider game that I know many people are very fond of. And I would like to be able to, as I say, make that available via ASP.NET using these technologies, but there's still some way to go before we get to that. I was asked a question before I started this, which I think I misunderstood. All of this stuff that I'm talking about now, the .NET Core stuff, sorry, .NET 5 stuff, is available on the Raspberry Pi. I haven't demonstrated that here today because I figured that 3 machines was enough and I didn't want to go to the 4th. So on that, I'll stop, and I've got no time for questions, but
there is one very quick question. You mentioned .NET 5 several times. There's a question about whether this will also work with .NET Core 3.1 or it's going to be .NET 5 only.
My feeling is that it's going to be version 19 of the interpreter only, and I would like to upgrade version 19 of the interpreter to use .NET Core 5. All the work that I've done has been with .NET Core 5. I think things will probably work with 3.1, but then that's the question there really is what version of .NET do we want to support with version 19, as opposed to what specifically we'll work on.
Okay. Right. Well, there are no further questions. So very well done on time. Thank you very much.
Well, I mean, I had to follow your lead on that because you finished bang on as well. Okay, everybody, thank you.